degrees of freedom for joint or pair. But now moving further, let us calculate degrees of freedom for some mechanisms or for some kinematic chains. Now for calculating degrees of freedom for mechanisms, we have a Kutzbach criteria, and according to this Kutzbach criteria we have one formula: F is equal to 3L minus 1 minus 2J minus H. Now here this F represents degrees of freedom, then this L represents number of links, this J represent number of joints, and this H represents higher pair. Now with the help of this equation we can easily calculate degrees of freedom for mechanisms. Now let us take previous example for calculating degrees of freedom. We have one fixed link, 2, 3, 4 links, A, B, C and D forms a turning pair. Now for this, let us calculate number of links. Number of links we have here are this 1, 2, 3, 4. So L is 4 here. Number of joints we have here are, we have A, B, C, D, 4 joints. And here higher pair is not present, so higher pair is 0. So according to this equation, F 3L minus 1 minus 2J minus H, its degrees of freedom will be 3 into 4 minus 1 . Its degrees of freedom will be 1. Let us take one more previous example of piston cylinder arrangement. This is our crank, connecting rod, piston, cylinder. Cylinder is our fixed joint, crank is second joint, connecting rod is third joint, and piston is our fourth joint. Cylinder is fixed, so cylinder is first joint. Now here, cylinder is fixed, so cylinder is first link. This 4 number link is our piston. Now here it forms a turning pair. Link 1 and 2 forms a turning pair A. Link 2 and 3 forms a turning pair B. Link 3 and 4 forms a turning pair C. And link 4 and 1 forms a sliding pair D. Now L, here are 4. Similarly J is also 4. Higher pair is not present here, so 0. Now F is 1 for this mechanism also. Let us take one more example of cam and follower arrangement. This is our follower, which is sliding in this fixed joint. This is with point contact with the cam profile, and this cam profile forms a turning pair with fixed joint. Now fixed joint is our link 1, follower is link 2, cam is link 3. Now this fixed joint and cam forms a turning pair A. this cam and follower forms a point contact or forms a higher pair B, and this fixed link and follower forms a sliding pair C. Now here we have L is 3, J here is 2, and higher pair is 1. Actually this J represent number of binary joints. Here in J we have one sliding pair, this one, and one turning pair, this one. So we have two binary joints here. This H is higher pair with which have point contact. This is our higher pair with point contact. If we calculate his degree of freedom, 3L minus 1 minus 2 times binary joint minus higher pair. So we'll get 6 minus 4 minus 1, we'll get 1. Degrees of freedom will be 1. Now here one main thing is to be considered, that all these three mechanisms will have degree of freedom B1. If degrees of freedom for any linkage combination comes out to be 1, then it comes under the category of kinematic chain. If F equal to 1, then it is a kinematic chain. These all forms a mechanism. In these all cases we have one input, and against that one input we get one desired output. So that's why its degrees of freedom is 1, and that is why it is known as kinematic chain or constraint chain. Like here we have rotational motion of cam as input and sliding or reciprocation motion of follower as output. This arrangement is used in engines for operating inlet and outlet valves. Likewise, in this mechanism we have input as a rotational motion of crank, and we have output as reciprocating motion of piston. This is the basic structure of engine. If we reverse it with, like, we consider this reciprocating motion to be input, then its output we will get will be a rotary motion of this crank. And for this, if we consider this rotary motion to be input, then we will get a rotary motion at this output. If degrees of freedom is 1, then it is a kinematic chain. If we consider next example, here we have one fixed link and these two links. If we calculate degrees of freedom here, degrees of freedom F will be equal to 3 into number of links are 3, so L minus 1 minus 2 into J here are 3, these 3 binary joints, and higher pair is not present, so 0, 6 minus 6. Here degrees of freedom comes out to be 0, which means that motion is not possible in this particular system. So it does not fall under the category of kinematic chain. It is a structure. Here motion is not possible. If F is equal to 1, then a constraint, here we get a constraint output. But if F is equal to 0, then here motion is not possible. We can take one more example. where we have this link 1 fixed, link 2, link 3 and link 4. So here we have 4 links. J we have here is 1, 2, 3, 4, 5. We have 5. Now here its degree, H here is 0. Its degree of freedom here is 3 into 4 minus 1 minus 2 times 5. It comes out to be 9 minus 10, which is negative of 1. If degrees of freedom turns out to be negative of 1, then it means that it is a superstructure. Here motion is not possible. In bridges, buildings, these all are superstructures. Their degrees of freedom is in negative value. As degrees of freedom in negative value got increased, then it means a superstructure is there. Now let us consider second example. This link 1, 2, 3, 4, 5. Link 1 is fixed. Here L is equal to 5. J is equal to 1, 2, 3, 4. J is also 5. H is 0. Here degrees of freedom will be 3 into 5 minus 1 minus 2 times 5. Here degrees of freedom comes out to be 2. So it is a unconstrained motion. It is an unconstrained chain, because here we will get undesired motion. Suppose if we consider this link 2 as input, we'll get more than one output, like 4 and 5. So more than one output are undesired motion. So whenever degrees of freedom comes out to be 1, it means that it is a kinematic chain. If it is 0, then it is a structure. Degrees of freedom is negative, then it is a superstructure. And if degrees of freedom is more than 1, then we have more than one desired output, or we can say we have more than one motion. Then this form a unconstrained chain. This does not form a kinematic chain. See, according to our definition, this does not fulfill our requirement. Like in our definition of kinematic chain, if all the links are connected in such a way that the first link is connected to last link, in order to form a closed chain, and if the relative motion in this closed chain are constrained, then such a chain is known as kinematic chain. It forms the closed chain, but relative motions are not constrained. Here we have unconstrained, undesired motions, so it forms unconstrained chain. So it is not a kinematic chain. So from here we can conclude that kinematic chains, we can conclude one more definition of kinematic chains, and that is, if any chain is having degrees of freedom to be 1, then only it will be considered as kinematic chain.